Hello, everybody. Welcome to the Art of Tracking radio show. Tracking is still alive and well. Join us as we interview master trackers from around the world. We'll hear their stories, their secrets. So tune in and enjoy all you hear. Welcome.
Welcome to the Art of Tracking radio show. Today we have a special guest on. We have John Huth. He's a Harvard University physics professor. He's also the author of The Lost Art of Finding Our Way. And I found out he is also a tracker. Hello, John. Thanks for coming on.
Oh, thank you very much, Garth. It's a pleasure.
So you've got quite a book here I'm looking at, The Lost Art of Finding Our Way. That's quite an encyclopedia of primitive techniques for navigation.
Yeah, it makes a good doorstop, too.
Yeah. How did you come about going from being a Harvard, or you're still a Harvard physics professor, but get into primitive navigation? Well,
so it's kind of an interesting story. Normally I do high-energy particle experimental physics. So I work at this accelerator outside of Geneva, Switzerland, called the Large Hadron Collider, and have a huge experiment, developed electronics for it and software, and did analysis. And there was a major discovery we had a couple years back. So I got into this by accident mostly. In 2003, my wife and I rented a house in an island off the coast of Maine called Little Cranberry Island, and I rented a sea kayak, actually a recreational kayak, from the woman that runs the post office there. Everybody sort of jack of all trades, does a little bit of this and a little bit of that. And I paddled the area the year before, so I had some vague sense of the islands and that kind of thing. When she rented it to me, she said she was out of compasses and didn't have any maps. And I thought, well, that's fine because I'd paddled around there before. So one day I was paddling, doing a circumnavigation of this island, Little Cranberry, and I remember there was this one little patch where there were some rocks that uncover at low tide, and it's kind of shallow, and what happens is the waves refract around another island and crash from on both sides of these narrows. So to picture the island, it looks a little bit like a C with the two ends of the C pointing south, and it's about 2 miles from each of the ends of the C, if you can picture that. And I was halfway across, so I was a mile across, and at that moment, a fog bank rolled in. And I thought to myself, oh, my God, I'm hosed because I didn't have a compass and there was just nothing but the Gulf of Maine off to one side of me. And I had to think quickly. I've subsequently read studies about people who are in survival situations, and people who don't survive tend to be dogmatic, that they just sort of force themselves into one golden rule of thought, and they just follow that until they perish. There seems to be another group who survive, and what they do is they seem to have their senses open up to all sorts of stuff around them, and time seems to move slowly. And I don't know if I'd call myself a survivor, but I definitely had this sense of opening up, and you had to, because either you paid attention to what was going on around you, or I would be in serious trouble. So the wind direction was out of the southeast. I noticed there were swells running from the Gulf of Maine from the southwest, and there was this big rocky beach to my northeast. It was not really even a beach. It was a bunch of boulders and a berm, and they're rounded and about the size of a football. So when the waves crashed up against this berm and the water trickled out through it, it made this loud grinding noise. So it was very distinctive. So I used these three things as a directional indicator and knew that I was a mile away from these shallows where the waves crashed on both sides, and I knew that I paddled at about 3 miles an hour, so I looked at my watch, I figured in 20 minutes I'd be arriving there as long as I could kind of keep my direction going. So I did paddle there, and sure enough, I hit this spot where the waves were crashing in both directions. And I should tell you that it was basically so darn foggy you couldn't see anything. I mean, it was a miracle. I could see to the end of my kayak. So I made it through this narrow opening and then turned north, and I then found that the lobstermen, they only drop their buoys so close to shore because, if you get to the shallows, you might crunch your boat up on the rocks. And so that was kind of a demarcation line that I could follow that gave me a way of finding my way around the island. And I also saw these little wakes from the lobster buoys from the incoming tide. So, this was kind of one of these things where I couldn't see anything more than a radius of about 10 feet from where I was, and yet I was getting all this information from sound and the waves and the wind and this other stuff. So I made it back in one piece. That was no problem. That was August 2003. Then go forward a few months to Columbus Day weekend 2003, and I was paddling outside of my house on Nantucket Sound, which is off Cape Cod, and I went out for another paddle. And again, I paid attention to the wind this time, although I was foolish enough to not have a compass with me. It was clear when I started paddling, but after about half an hour or so, fog rolled in again. And because I knew the direction of the wind, the coast runs east-west, so all I had to do was to turn to the north, and I would catch a glimpse of the coast and basically handrailed, followed the coast until I got back to my house. And that was fine. No problem. I pulled my kayak up, had a shower, went out to the movies with my kids, had dinner, and good time. The next morning, however, I went out and paddled, and I got stopped by the harbor master, and he asked me if I had seen two young women who had been kayaking. And I said no, and I asked him, when did they go out, and so on. So he said that they had gone out about 3 o'clock the day before. And I said, I was out exactly then. He said they got lost in a fog bank. And I said, my God. And I was in that fog bank. And turned out they'd put out about maybe a quarter mile from where I put out, and at the same time. And they told their boyfriends they would be out paddling for maybe 10 minutes. But after 45 minutes, when they didn't show up, the boyfriends called the authorities, and there was a huge search and rescue mission going for them. And the next day, they found the body of one of the girls and never found the body of the other young woman. Now, the thing is that if you read something like this in the newspaper, it's tragic and, you're pretty sad about it. But if you're doing the exact same thing at the exact same time in the same place in the same conditions, and you have a good time and two people die, it can really hit you hard, and it hit me hard. And so the first reaction is to ask why, but you can't ask to see why because it just kind of crashes and foams, that kind of thing. So I became obsessed. It was kind of a way of working off this sense of survivor's guilt. And so I started to develop these my own techniques for navigating using natural signs like the stars. I would memorize the positions of major navigational stars, have little 3x5 cards that I flip over with the names of stars and their coordinates and the path of the sun in the sky, and using shadows as a natural compass, and be able to forecast the weather by looking at the clouds and know when wind shifts might occur and how they might occur, and this kind of thing. And then I found that I wasn't alone, that this was common to a lot of cultures like the Polynesians, the Norse, Arab traders in the Indian Ocean. And what happens is these cultures are able to tune into their environment to navigate. And it was, I guess maybe it shouldn't have been a revelation, but it was. And I had, all of a sudden, after a year of doing this, I found that I looked at the world differently. The sun's position in the sky had meaning, the clouds had meaning, the stars in the sky had meaning, and it was quite an epiphany for me. And about the same time, people were starting to use cell phones and text a lot, and so I see people in the parking lot of a grocery store, and they'd be walking along with their cell phones and completely engrossed in the cell phones, and I had this kind of irrational fear that their lives were in danger. And so my first impulse was to go up to them and shake them and to say, hey, your life is in danger, don't do that. But that seemed to me to be relatively dangerous. So I started to teach a course on the subject, which seemed like a good outlet for my energies, and I started to teach this to students first as a freshman seminar, and now I'm teaching it to students as a general course. And the thing is, we go outside, and the students will memorize major stars, for example, and then the quiz, they come up to the roof of the Science Center at night, and I point at stars and I say, what's that one, and which way is north, and, what's your latitude, by looking at Polaris and that kind of thing. It turns out it's something that can be taught. So there was no book about it, so I ended up writing my own notes, and then pretty soon I thought it might be of general use to people, so I put all my stuff together in a book that I think is accessible, and it works probably on a level if people are curious, but if you want to go out and practice it, it also gives you something of a guide to practice it and kind of learn the same techniques.
Yeah, it's a great book, and there's really not too many books out there on this subject, so that makes it all the more valuable.
Yeah, thanks. I think what I tried to do was to touch about as many bases as I could. I think the topic of amateur weather forecasting, for example, is pretty gone out the window, but even these other things like paying attention to the stars and knowing the motion of the stars in the sky, maybe a generation or two ago, people knew that, but, I couldn't find it. I had to kind of learn it on my own, basically, so I could put it down on paper.
Yeah, it is. You were mentioning how it changed the way you felt about your environment. You feel more connected, and I noticed that myself when I first got a job in downtown Portland. I knew nothing about the area, and I just stared at the map until I figured out, okay, what is the dividing line for north and south and east and west, and avenues mean it runs north and south, and just figuring all that out felt like a revelation. It felt pretty empowering.
Yeah. It's interesting because the way people learn an environment is this process. So there are two kinds of knowledge. One is called root knowledge, and one is called survey knowledge, and that's what psychologists talk about anyway. And root knowledge is the idea that there are these paths and intersections that you follow, and normally when you're new to an environment, you will start out just knowing a few of the major paths, and so you get from point A to point B by following those paths you know. But over time, you develop survey knowledge, which is kind of as if you're hovering over the landscape looking down, like you were looking at a map, and you then have this in your head. And then you ask the question, well, how can you tell the difference between somebody who has root and survey knowledge? And there's a pretty easy answer. It's shortcutting. So if you're in one place and you want to get to another place and you know roughly where the other place is, rather than taking a known route, you might say, well, if I go down the street here, I'll basically be able to, get over to my destination with a little bit of fussing about. And it's interesting that most mammals have this, and even birds have this. So there was a study done back in the 70s of wolves, and it was found that young wolves would have to follow their parents, and they had root knowledge, but the older wolves had survey knowledge and would learn shortcutting behavior. So it's not exclusive to humans. It actually happens in most mammal species.
So what are some of the elements of human navigation?
Well, the one that's the most common to us and other mammals and even some insects is called dead reckoning. So the idea is that you, number one, have this map in your head of your environment, and then you determine your location from the history of your travels. So you travel in a direction for a certain amount of time, then maybe you change direction, and then you walk for another amount of time in that direction, and yet you kind of mentally keep track of that progress against the landscape. And that can be done in a methodical fashion, like sailors in the ocean actually record the distances and paths, but in a way we're intuitively aware of that, and you kind of integrate, if you like. You add up all the little paths until you figure out where you are. So that's the most common way people navigate, and you can see in our language that The words for distances, like mile, comes from Latin, the word for 1,000 paces, so you just keep track of how many paces you have. And then directions usually come from natural signs in the environment, like east is associated with the position of the rising sun, and south is associated with the position of the sun in the midday, and west with the setting sun, and so on. And so you can just peel back the languages of positions, directions, and distances, and you'll immediately see that there's this connection with our human nature and the environment, basically. So that's the most basic way of doing it.
Yeah, that's fascinating. So our language, the words we use for things like mile and for distances and directions, those words have a history that tell a story.
Exactly. For example, in Latin, the word for north is septentriones, which means the 7 plow oxen, which is a reference to the Big Dipper, because a lot of people think of the Big Dipper as a plow as opposed to a bear. So, you orient yourself to the north by looking at the Big Dipper. And the North Pole was never marked by Polaris until about 1400, and so if you go back in ancient times, the Big Dipper was much more of a indicator of north. So you see that in Greek culture too, Boreas, and also Native American cultures have the same tradition with the Big Dipper as well, and their language. Native American languages also reflect this, sort of Aboriginal languages reflected, languages in the Pacific reflected. So it's pretty universal, pretty global to see language reflecting these clues for how to find one's way.
So if we look to the sky, what kind of things will we find in the sky that will help us navigate?
Well, you have to tell me if it's day or night, or if it's cloudy. Or
let's start with day.
Okay. Well, if it's day and it's sunny out, then the first thing is if the sun is close to the horizon, it's either rising or setting. Now, that means it rises in the east, but the sun will rise in the wintertime somewhat to the south of due east. Summertime will rise to the north of due east in the summertime, and rise to the south of due east in the wintertime in the northern hemisphere. And what helps is to get a sense over the course of a year of the passage of the sun, because it's high in the sky in the summer and rises and sets north of due east, due west. And kind of the character of light in the summer and winter also kind of give you a clue for where it is in the sky. So my parents, for example, will look out their window when they're eating breakfast, and they have a view of the eastern horizon, and they have kind of a little sun calendar where they associate sunrise with different times of the year. So there's a bit of tracking over the course of a year, and you start to develop an intuition for directions just based on the character of the sunlight, how high it is in the sky. And so you don't, in a sense, even need a watch, because you kind of get a sense for that time of year, the height of the sun, and the character of the sunlight, kind of which direction is south, northeast, and west. So that's one thing you can do. Another is the prevailing winds, and the prevailing winds usually have a fairly predictable pattern. So I live in Boston, and in the summertime the prevailing winds are out of the southwest, and they bring moisture from the Gulf of Mexico. And so if you see certain cloud formations and feel warm, moist air, like I am today in Boston, you associate that with winds from the southwest. So that makes a good wind compass. Or in the wintertime, the winds typically are from the northeast or northwest, and they come from Canada, and it's cold, dry air and clear blue skies, so you associate that with winds from the northwest. And then if winds are blowing from the east, they're typically coming off the Atlantic, and they're kind of cold and moist and bring in this low deck of clouds called a marine deck. So during the day, you got the clouds and the wind direction and the sun as all kind of clues. So the the nighttime, you have to be used to the passage of the stars in the sky over the course of a year, because typically the stars will move about 1 degree to the west relative to the sun. So they'll be rising at a slightly different time and setting at a slightly different time each day of the year. But then you get used to the patterns and the fact that they move then at about 15 degrees per hour across the sky. And so if you're used to the patterns, like Taurus looks like, or Gemini looks like, or Orion looks like, and you know the progression of these stars from, let's say, west to east, then you can almost immediately get a sense of orientation. So if I were to give you an outline of North America, right, an outline of North America on a map on a piece of paper, and I just rotated it at some funny angle, and I said, okay, rotate it to north is up. You can do that because you recognize the shape, you know what Florida looks like and the Hudson's Bay looks like and that sort of stuff. But if you spend enough time looking at the stars, everything kind of falls into place immediately, and pretty soon, even if you're catching a glimpse of a few stars when you get a break in the clouds, you can start to orient yourself at night just using a few stars that you see in breaks in the clouds. So that's also a skill that can be developed.
So, yeah, there's a lot of a movement, I guess, we got to take into account. So the Earth's going around the sun, the moon's going around the Earth, and then since the Earth is going around the sun, we're in a different spot every day, and that's what gives us the 1 degree difference of the stars.
That's exactly right. So the way we do time, the way time on Earth is figured is by the sun, and we try to make noon on average, local noon, having the sun at what we call the meridian, which is an imaginary line that goes from north to south. And that's just because our sense of time comes from sundials. So since we're orbiting the sun is going to appear at different positions each day with respect to the background of fixed stars. And so since we reckon time based on the sun, what's going to look like, it's going to look like the stars are moving to the west 1 degree every day. And so you have to keep in mind that. So to give you an example, just after sunset, if I look up in the sky now, I see something called the Northern Triangle, which is the stars Vega, Altair, and Deneb, and Cygnus is sort of contained in that, which is the Swan. But then if we go to, January, the stars have moved enough that just after sunset I'll see Orion high in the sky, and then Sirius and Procyon just to the east of them, basically. So you have to kind of know that, so you kind of know what to expect at a given time of the night, for example. And it may take a few months or a year to catch on to it, but I found that students can catch on to it quite readily.
Yeah, is there certain constellations or things you introduce them to first?
Yeah. So one of there are some easy tricks to do. Like everybody kind of knows the Big Dipper because you're talking about 7 stars that all are roughly the same magnitude, and so I kind of start with the Big Dipper as the jumping off point. And then if you look at the end of the ladle, you trace from the bottom to the top, and you go maybe about 5 times that width, you'll hit Polaris. So that gives you a reading to north. And then if you go again another 5 times that width, you'll see this thing that looks like a W or an M, depending on which its orientation in the sky, and that's Cassiopeia. So Cassiopeia and the Big Dipper kind of bracket Polaris, if you like. And so that's the easiest starting point to go from. And then we start to walk around. So if you follow the handle of the Big Dipper, there is this phrase called arc to Arcturus and then spike to Spica. So Arcturus is this bright star that appears in the sky, usually just after sunset, starting, let's say, in May. And Spica is just a little bit below the celestial equator, and so you can kind of follow this arc in the sky. And so that's the first thing. And then there's this whole passage of stars that are in a belt that we call the ecliptic, which is the passage of the sun, and there's a lot of mythology. So I teach them the mythology. So you have the 7 sisters, which are the Pleiades, and then Behind that is Taurus, which is the bull, which is guarding them from Orion the hunter, which is just to the east of that. And then following Orion, you have Sirius and Procyon, which are Orion's faithful hunting dogs. And so you basically build off of these ideas like Arcturus, which is a little jingle, and then the mythology that the Greeks probably used precisely to recognize the stars. And then so you start from this kind of local perception, and pretty soon when you integrate that all together, you kind of get a global view. And so that's how I teach it. And I also have the students memorize the coordinates of the stars that I don't expect people reading my book to memorize, but it actually helps you identify the stars readily, especially in an urban environment where things are a little bit dimmer and harder to see.
What do you mean by the coordinates of the stars?
Yeah, good question. So you know that we're at a certain latitude. So the stars, in effect, have a kind of latitude. So let me give you an example. We call the latitude of stars, it's basically the angle above the celestial equator. So the celestial equator hovers over the equator of the Earth, so 0 degrees, and then there's a celestial north pole and a celestial south pole. They're plus and minus 90 degrees. So there is the idea of a zenith star, or a star that once every 24 hours will pass directly over your zenith, directly over your head, pure vertical. And that star would have a declination that's equal to your latitude. And so, for example, if I'm here in Boston, I look at Orion. You look at Orion's belt. The right-handmost star in Orion's belt is exactly over the celestial equator, so that's at 0 degrees. And it's pretty, it's not that low in the sky, but, it's maybe, 40 some odd degrees up in the sky. But then I go down to the Caribbean on vacation, and all of a sudden Orion's almost on top of me. And so you get a sense of your position just from looking at the altitude of these stars above the horizon and your latitude. And so this idea of declination is a number that you can assign to it. So to give you a more concrete example, there's Vega and Deneb, which are two stars in the Northern Triangle. And one is at 39 degrees and passes just a little bit to my south, and one's at 45 degrees and passes a little bit to my north. And so it splits my zenith, basically. So if you memorize those declinations, then you can basically map that into, stars that will pass over your zenith or pass over somebody's zenith somewhere on the planet Earth. Right? Yeah. So somebody on the equator would have that. Then there's longitude, which is a little tougher, but at some moment the stars will pass over somebody's longitude, and that causes a separation in the other direction in the sky. And so what we do is we memorize not only the positions of the stars as numbers, but we associate them with locations on the surface of the Earth, so that if you know something about objects on the surface of the Earth, where's New Delhi and where's Beijing and where's Perth, Australia, or something like that, you can kind of then get an idea of how the stars would map into locations on Earth. And that, what I find, gives people the ability to form this map of the stars. So the numbers are kind of a intermediate point to memorizing the pattern of the stars, basically.
Wow, that is fascinating. Yeah.
That works for you?
So,
okay, good.
Yeah, if thinking about latitude, so if I look up at the stars, I'm in Portland, Oregon. We are at about 45 latitude, I think it is.
Mm-hmm. Yep.
And I look at the North Star. Does that mean the North Star is going to be 45 degrees above the horizon?
Yep, exactly. The most wonderful thing about Polaris, the North Star, is that the angle above the horizon, so you just draw, basically a straight line down to the horizon, that angle translates directly into your latitude. And we take the students out, and they have a protractor and a little string hanging down, and that's one of the tests that they have to pass, is to, find out their latitude from that.
That's
pretty
cool.
thing to do. Yeah.
So
it is, actually.
When people did sailing and stuff like that, the latitude was fairly easy to find because they could use the North Star and see where they're at. That number would tell them. But the longitude was a whole different story. That was
yeah.
That took the invention of the clock or something, or you had to know time and somehow.
Yeah. So the issue with longitude is the Earth rotating about its axis. It's like a big merry-go-round. So if you're at, let's take your latitude of 45 degrees, anybody at 45 degrees at some time in a 24-hour cycle is going to see the same pattern of stars, basically. And so the question is, where are you? So people didn't really know how to solve that problem exactly. In the Middle Ages, the actual thought was you could maybe use the moon to do it. So I think even back as far as Aristotle, picture the following. Let's say somebody was on the moon and set off an explosion that everybody could see, okay? If you made a timing between the sunset and this explosion on the moon, that time difference would be different for different people on the globe, okay? So you could actually distinguish the rotation of the Earth because you would have something that everybody would see at the same time. You get what I'm saying there? Yeah.
Yeah.
So one example of that would be a lunar eclipse. So the moon passes into the Earth's shadow, and that's all happening at the same time for everybody on the planet. So if you did a timing between sunset and a lunar eclipse, you could actually get your longitude if somebody, had worked out the numbers. And in fact, Columbus did that on his fourth voyage. He actually used some tables that were in effect used for astrology, but he used it anyway to get that. So that's not terribly precise. And then I guess there was the idea that if you had a very precise clock, you could set it to the time at a prime meridian. So the sun is right over this imaginary north-south line in Greenwich at a certain moment that would be the Greenwich noon. And if you have a clock set to that and you find that, the sun's just rising, at that moment of Greenwich noon, then, you'd be 90 degrees to the west of it. So you could kind of use that clock to figure out where you are. So this was suggested in the 16th century, but nobody had a clock that was accurate enough to do that. And then, again, it was suggested in the 17th century by an astronomer named Christian Huygens, who invented what we call the grandfather clock. And in principle, you could have done it, but the problem is the grandfather clock has this pendulum, and if you put it on shipboard, it's just bouncing around too much to really be accurate. So it took, in the 18th century, an inventor named John Harrison to put together these kind of gearing mechanisms that would compensate for the accelerations and bumping up and down on ships and temperature changes that were needed to get the kind of accuracy to do that. So that's, in a way, not the end of the story. I mean, if you permit me. Also, people still use the moon because the moon moves at about half a degree per hour in the sky, so it acts like a clock. So if you knew precisely the orbit of the moon and you had precise enough observing instruments, you could boil that information down and give you a longitude as well. So kind of by the end of the 1700s, although the chronometer in principle could work, nobody could afford one. So from about 1800 to 1850, people used this lunar technique with the moon, and it was quite well established. So, for example, Nathaniel Bowditch, who was from Salem here in Massachusetts, developed a technique for merchant seamen and whalers to boil down these lunar observations to a longitude. And then about 1850, these chronometers came down in price enough that people could use them. And it's much more conceptually simple to know that the clock is telling you the difference between Greenwich time and our time by doing observations. So that's kind of a long way of getting at the answer, but that's how it came out.
So what about, let's take this to the forest or something.
Mm-hmm.
How are being trackers and stuff, we're out in the forest a lot, and it is easy to lose your own trail out there and find your way back sometimes. So what can we do as forest walkers to help us?
Well, it kind of depends on the activity that you're engaged in. I mean, I personally have done different kinds of tracking, so I find that if I go off trail, I have a much better chance at finding something than being on trail. So, I mean, I'll always bring a compass with me, and I have something of a backup plan. The easiest thing to do, and this is true for just a lot of environments and a lot of cultures did that, is identify a feature that's linear. And by linear, I mean like a river or a road or something that you know you can intercept if you just walk in roughly the correct direction. And then there's even a technique called deliberate compass offset, which is to say maybe you want to reach, I don't know, an airfield or something like that that's along a river. Instead of walking right to the airfield, you actually walk, let's say, a little bit to the left of that position. So when you reach the river, you then know that you follow the river, I guess, let's say, to the right to find it. So a little bit of forethought goes a really long way to avoiding problems like that. So whenever I start out doing things, I mean, even if I don't have a compass, what I'll do is I'll look at the wind direction, I'll look at where the sun is in the sky, I'll look at the clouds, and sometimes the clouds aloft will carry directional information longer than clouds on the wind on the ground. And then I'll think about what's the strategy if I get turned around. And I think a lot of the problems that people have is they'll just go, tearing off after something in the woods without thinking about that strategy ahead of time, and that contributes to them getting lost. So that was what I did when I went out kayaking. I went out yesterday in the woods because I was doing a video shoot, and the first thing I did was to because we were like doing bushwhacking basically. So I paid attention to the wind direction and is there a linear feature that I can intercept and that sort of thing, like a road. And it's happened to me a couple times where even the maps were wrong. I don't know if you've ever experienced that, but if you carry a map with you, you can't always count on the features being correctly drawn on the map, and every so often I get surprised. So you always have to have a plan B and have multiple ways of finding your direction. Sometimes you could be holding your compass right over a chunk of iron and it throws it off completely, and then you have to scratch your head a little bit and say, well, does that make sense with the position of the sun in the sky and that kind of thing? So it's always important to have some redundancy and a plan ahead of time and that sort of thing, and then don't trust any one thing but have multiple signs that you look at.
Yeah, I volunteer where we do snow tracking surveys, and we bring the public up to Mount Hood and go out for animal tracks. And that deliberate offset that you have in your book, what you were talking about there, where you have a linear thing, I always pick my locations that I'm going to go to that have some kind of a linear thing, and I tell everybody, okay, we're going up this way, make sure they look at the map, so if we get lost, you just head this direction and you're going to hit that road or that river or whatever. Yeah.
It works in almost any environment. I kayak a lot off the coast of Maine, and getting caught in the fog is pretty common. And so a couple times I'll lay out a route ahead of time, but then sometimes the route will just skirt the edge of islands, if you know what I'm saying. So then if the fog rolls in, what I'll do is rather than skirt the edge of the islands, alter my course so that I actually hit the island, and then I can do what's called handrailing around the island, which is sort of you keep the coast on one side of you. But in the woods, you can do pretty much the same thing, with a road or even natural features. Like if you know that you're getting a slope that's always, pointing in a certain direction, you can use that as an aid to kind of help you find your way. I often just use, the topography that appears on the map to help me find my way, which you can do pretty efficiently if you're used to reading the contour lines.
Yeah, we. What about one of the things since I've been reading your book is looking at the landscape a little bit differently, and just looking at how the plants and trees are growing, if I can get any clues about direction from the plants and the trees and just the way things are growing in the ecology.
Yeah, that's definitely true. There are a lot of trees are phototropic, so that means that the branches tend preferentially to grow on the south side and in the northern hemisphere. So, I tend to become a student of treetops because, one thing that's a little tricky is they'll avoid each other because, they don't want to get tangled up and they get more sunlight if they stay away from each other. But if you start to pay attention to the tree growth patterns and the way they're branching in relationship to other trees around them and hillsides and stuff like that, you can get a pretty good idea what's going on. Another thing is the direction of prevailing winds. So to take one example from your guys' neck of the woods, you tend to have winds that are coming off the Pacific, and if you get up into the Cascades, especially when you get near the crest of the Cascades, you will typically get pretty strong winds out of the west, and that will force the trees' branches to grow in an easterly direction. So, if you get lost in the fog on a ridge and you just see that all the tree branches are pointing in one direction, you can be pretty sure that that's east if you're, in a certain part of the Cascades. So I've actually done that a couple times. I was up in Washington State and along the Pacific Crest Trail, and fog or clouds closed in, and so we, found our way using that trick.
Yeah, my parents have some property on the east side of the Cascades, and there's a Doug fir tree on their property that there's no branches on the west side of it. And I was actually out there in the winter. Every time I go up there, I keep a weather journal, which way the wind is going and stuff. And I was out there in the winter, and the wind was coming from the east, and I thought, well, why are the branches growing into the wind? So I went back and looked at my weather journal, and come to find out, during the growing season, the spring and the summer, the wind was from the west.
Yeah.
So when the branches were trying to grow, it was getting hammered with the wind, and in the winter, the wind was coming from the east. So I thought that was really cool to see that.
Yeah, probably in that case you were getting like one of these Pacific storms that had a circulating air pattern around it, and when you get these lows where you'll get airflow that's circulating in a counterclockwise direction, you'll frequently get storms off the Pacific that'll have that kind of circulation. But as you say, in the wintertime, it's not going to really affect the growth of the trees, but in the summertime you get a different pattern. So that's exactly right. And I do the same thing, in my neck of the woods, is keep track of the prevailing winds in the time of year, and we have the same thing, that we get a lot of growth in starting in April but into May and June, and that's when we get a shift into the southwesterly wind pattern, wind coming out of the Gulf of Mexico, basically. So it's the same idea, but just slightly different wind patterns.
Is there any? Do you find yourself looking at the weather a lot and trying to predict the weather?
Oh yeah, all the time.
Yeah.
Basically all the time. I ride my bike in and out of work, and so I'm always trying to match my predictions against what happens the next day. And sometimes I can beat the weather forecasts because you get more local information, right? Because the weather forecasts are based on computer models and this kind of thing. But your eyes are actually looking at much more fine-grained detail of what's going on, and so sometimes you can do a better job. And I teach this to my students, and they have to not look at the internet and make predictions for the weather the next day and see how well they do. And at first they don't do too well, but by the time they're done, they actually have really picked up on it. And my kids do this. My wife does this. We once. Wow,
that sounds like a lot of fun. I'm going to have to start a journal for that.
Well, we were walking back from so there's this thing called mackerel scales and mare's tails. You ever hear that jingle?
No,
mackerel
I haven't.
Scales? Okay, so there's a jingle. It's mackerel scales and mare's tails make lofty ships carry low sails. And if you look back in history, people had to predict the weather, and so there are all these jingles that aided people in predicting the weather. So what this means is mare's tails are kind of cloud formation that are these wispy cirrus clouds that you'll see in the sky. So oftentimes you'll see a clear blue sky, and then these wispy mare's tails will come down. And then after that, there will be mackerel scales, which the technical term is cirrocumulus, but they're these very high clouds that the pattern of them is sort of regular squares that resemble basically the scales of the mackerel, the fish. And so those are the first harbingers of a warm front coming through, and then what happens after that is you get lower and lower clouds in the sky until you actually get the rain. And so it's a very predictable pattern for a warm front to come through. I was out canoeing with my wife in the Minnesota-Ontario border country, and I was looking up at the sky one evening, and I said, "Oh my God, mackerel scales and mare's tails, we're going to get rain tomorrow." And she said, "What the hell are you talking about? You don't, like I was insane." And sure enough, the next day, it was cloudy, and we started portaging, and just buckets and buckets of rain came down, and she ruefully said, "Oh, I guess you were right." So many years after that, we were walking on the beach in Cape Cod and coming back from breakfast, and she said, "Oh, look, mackerel scales and mare's tails, we're going to get a storm." And sure enough, about 2 or 3 hours later, a huge squall line came rolling through and everything. And so she'd basically picked up on it. So
yeah.
Definitely, over time you start to learn and you start to get instinctive about it too. And it's fun. I mean, people think you're miraculous, but it's just, having the powers of observation. And for people like trackers, you can appreciate that you start to see things that other people can't see, right? So.
Yeah. Yeah, speaking of weather, I was having a conversation with somebody the other day, and it kind of revealed something. I was talking about what I thought was warmer weather is lower pressure, and then colder weather is higher pressure, but they were saying it was the opposite. And what we found out was that I guess it depends on the system you're talking about, because in most sciences, I guess, that if you heat up a canister, you're increasing the pressure, but when you're in weather, if you heat up something, it's actually decreasing the pressure because everything's going up. Is that right?
Yeah. If you start to think of it from like your basic physics or chemistry you learned in high school, you'll actually get kind of messed up. The first thing to know is that we live in a pressure equilibrium on the surface of the Earth. And you ask, what does that mean? It means that the pressure differences from one place on the Earth to another are actually very small compared to the pressure differences as you go up in altitude. And so what happens is that any major pressure difference on the surface of the Earth is going to cause wind to blow, which is going to equalize the pressure rather rapidly. So the things that drive like a low pressure system and a high pressure system are actually pretty small differences in pressure. So to do a good approximation, you have the same pressure in the wintertime as you have in the summertime. What changes is the density of the air. Okay, and so that means that in the wintertime the air is much more dense than in the summertime. So if you go to Lake Tahoe or someplace up in the mountains where you have airplanes taking off, they'll have a much more difficult time getting lift in the summertime because the air is less dense. So what kind of happens is you picture a column of air going up in the sky, and so if it gets hotter, that column of air basically rises, so you get the same pressure. So to the first order, the pressure is the same everywhere. Then to the second order, warm, moist air tends to be less dense. And part of that just has to do with the fact that it's rising more rapidly, because if you picture a balloon and you heat up the balloon, it's going to rise. So a little parcel of air that's warmer than its surroundings will rise, and so as a result it expands and becomes less dense. So you're right, it's totally counterintuitive, but you have to start to think about the fact that the air can rise and fall, and then when you start thinking about that and it's not really constrained like it's in a box, then it starts to make sense.
Yeah. You got a great section in your book on lost people, and you have what says, personalities and behaviors can help searchers.
Yes.
Can you explain that a little bit?
Yeah. Well, I learned about this from a couple of people. There's this one guy, Robert Coster, who he's in Virginia, and he has the world's largest database of lost person behavior. And you might ask, why on earth would you have a database like this? Well, it turns out it helps search and rescue missions greatly because they can efficiently deploy their resources. So if you take a lost backpacker or a lost hunter, typically they'll be found quite some distance from the last point where they were known to be. And so you have to deploy your resources in some direction, some broad swath. And they'll typically be more likely to be found downhill because a lot of people have been told that if you want to find your way out of a situation where you're lost, you go downhill and you find a creek and then you follow the creek and that kind of thing. On the other hand, children, especially young children, will just tend to seek shelter because they don't have a well-formed map inside their head of their surroundings, and they're more interested in comfort. So they'll be found very close to the last point where they were known to be, or Alzheimer's victims who frequently do get lost because they get, there's something else is going on in their mind. And again, they'll be found very close to their last point they were found. And so depending on what you're doing, a hunter, a mushroom picker, a tracker, he has all these different categories for them. And so depending on who you are, you'll be engaging in different sorts of behavior, and, getting lost will happen in different ways to different people.
Yeah, and I heard you have a word in there that I haven't heard before, the map bending.
Oh, yeah, sure.
And that's like stages of getting lost, or? Yeah,
so that comes from a sport called orienteering, where what happens is there's a course you have to run, and you basically about 1 minute before your stage to go off on it, you're given a topographic map and you're allowed to have a compass, and then you try to find your way from one waypoint to the next that's marked on the map. And frequently what will happen is people will think, or they'll want to think they're in a certain location, and so they'll deliberately ignore information that is not consistent with where they think they are, right? And then only attend to information which confirms where they think they are. Basically, it is a psychologists call it confirmation bias, and I can tell you,
ignoring things that they should be, or that they're ignoring things that are contrary to where they think they are.
Yeah, exactly. And so this is one of the tricks to not getting lost, is to kind of have an open mind, because if you are dogmatic that I am here, you'll start to interpret things on the map incorrectly. And so I've seen this happen on backpacking trips where once I was with my brother-in-law in eastern Washington State, and we were hiking downhill, and we were in an area that was pretty arid, so there were these springs along the way, and the springs were probably maybe 5 or 6 miles apart, and it was quite hot. So we had this one spring where there was basically a tent site that we were aiming for, and because we were going downhill, we were going faster than he was used to, and I saw this spot that I thought looked like the spring. And he said, no, it can't possibly be. We aren't there yet. And I was there triangulating with my compass and all this other stuff. And we got to this little grove of trees and a little trail running off to the side. And I said, this has got to be the spring. And he didn't believe me. And I said, well, let's stop here, and your son can go down the trail for 10 minutes, and my son will go down the side trail for 10 minutes, and then they'll come back, and then we'll figure it out. And he still couldn't believe it. My son went down the trail, and he got impatient. He started going down the trail after his son, and just as soon as he was out of earshot, my son yelled up to me and said, Dad, the spring's down here. I said, oh, great. So he comes back up, and he says, well, where's Uncle Ken? And I said, well, he went down the trail. And so we didn't know if he was coming back or not, so my son kind of took off all his gear and got a water bottle and went running off after Ken and brought him back. Ken still couldn't believe that we were at the spring, and we hiked down there, and there was water water gushing out of the ground in a little tub and beautiful little tent site, and somebody had even chopped up some cordwood and had it on the ground. And it took him an hour or 2 hours before he actually believed that we were at the spring. And it was all because he was convinced that we were not traveling as fast as we were because we were going downhill. And I was basically trying to, take every last drop of information I could get. So he was clearly map bending in that case. So there's a good example of map bending for you.
Yeah. So you get a picture of the map in your mind, and then when you realize, comes to a point where you realize, hey, wait a minute, this is not matching up. That's where panic sets in a lot, probably, huh?
Yeah. It's actually there's a kind of universal anxiety at being lost that people have, and so that moment of realization is probably the best time to just sit down and do nothing, because people will frequently get themselves into more trouble when they panic because they'll go off in some direction and then get even more confused. So in North America, a phrase for this came up called woodshock, but it turns out we aren't the only people to experience that. The Vikings experienced it when they would be lost at sea. They had a word for that panic at being lost and not being able to regain their orientation. And even in the Pacific Islands and the Marshall Islands, the navigators out to sea had a word for being lost and not being able to find their way. So it's actually a pretty universal human experience. And it's very unnerving. And the hardest part is to stay put and not do anything until you sort of thought through a plan and figure out what's going on, because the human instinct is to try to do something to get out of the predicament, and that's probably the worst thing you could do. Yeah.
When you were writing this book, did you come across a lot of myths things that you've heard that you throughout your life that turned out not to be true or anything?
Yeah. Well, the one that comes to mind the most is the moss on the north side of the tree myth. And early on, I gave one of my students a final project to investigate it, and she found that it was kind of spotty, that it worked some of the time, but not all of the time. And so I got kind of intrigued by it. So the idea, there's an idea behind it which doesn't always work, and that is in the northern hemisphere, the sun arcs through from the east over the south to set in the west. And so the south side of the tree is exposed to the sunlight more often, and the north side of the tree is in shade. Moss is a plant that lacks roots. It's non-vascular, so the only way that moss can really get moisture is by collecting dew. And so if it's in the shadow, it'll collect dew and can tend to grow. So you can imagine if you had an isolated tree on flat ground, odds are moss would be growing on the north side of it. But the problem is that it's a lot more complicated than that. So if you're deep in the woods, there's a good chance that every part of the base of the tree will be in shade, and so you'll see moss all the way around, and it doesn't act as a terribly good directional indicator. Sometimes people will confuse lichen for moss, and so you have to know the difference. And then sometimes there's a kind of algae that grows on trees that sometimes people will confuse with moss, but also tends to grow on the north side of the tree. Different trees, they grow differently. Moss grows differently on them. So like smooth bark trees like aspen, birch, or beech won't get moss, whereas oak trees and maple trees will. And dead trees will have moss all around them because they tend to have more moisture. So there are all these other factors that come into play, and you have to be exceedingly careful to make it work. And it was funny that for a long time, up until about the turn of the 19th into the 20th century, people took this as gospel, and then over time, people realized that unless you're really, really, really good at it, you can't count on it at all. But I spent years out in the woods and just staring at the bases of trees and looking at how moss grew and trying to figure it out and that sort of thing. And then I traced the history of it and what people wrote about it in the past and that sort of thing. And it was just fascinating to, find out how, it started out as something you could count on and then turned into something that, it didn't really work too well, and then found out why. So it was, sort of like a mystery, trying to recount what's happening at the scene of the crime, basically.
Yeah, I've looked at that myself, and being in the Pacific Northwest, there's moss everywhere. So the only times I did find where it worked was on a tree that had nothing else by it. It was totally exposed to the sun, and then some of those I could find where there was moss on the north and not the south side.
Yeah. Well, there's also an issue in the Pacific Northwest of the prevailing winds and the fact that you got a lot of moisture in the winds coming off the Pacific, and so that's going to influence moss growth just as much. I talked with a guy named David Birch who runs a School of Celestial Navigation in Seattle, and he talked to some of the people that at the University of Washington, and they basically said that the prevailing winds can make a huge difference in moss growth. So there you go.
Yeah. You've got a fascinating section in your book on waves and how the Marshall Island people can figure out waves in between all the islands and tell where they're at. That is just absolutely fascinating. They have these little stick charts, it looks like, made out of sticks woven together that teach them about this.
Yeah. I knew about this while I was writing the book, but in the process of writing the book, I ended up collaborating. I'm still collaborating with an anthropologist in the University of Hawaii, and he's actually gone out and working with a Marshall Islander who's trying to revive the tradition of wave piloting. And this guy was taught by his grandfather how to do wave piloting, and there are a few old-timers who kind of know about it, but the idea is something like the following. You remember when you were asking me about how I got into this in the first place, and I told you that I was paddling around this island off the coast of Maine, and there were waves that were breaking in opposite directions along this little shoals. The reason they were breaking in different directions is because they refracted around this island, and so you had waves that were coming from kind of the southwest, and they get bent around when they reach shallower water, because water waves, when they encounter shallow water, they tend to slow down. So if you ever look at a coastline, like you're on a beach or something, you typically will see the waves just coming in where the wave crest is parallel with the shore, right? I mean, people are pretty familiar with that. But you might look out in the ocean and you actually see the waves are moving in a different direction, and that's because as the waves approach the shoreline, they slow down and they get bent, so their wave faces are parallel to the shore. So let's imagine that you have a swell coming from the east and impinging on one of these islands. What will happen is the waves will bend around, and so on the leeward side of the island, that is the side away from the direction of the waves, you'll actually get the waves crossing over. So the waves from the south side of the island will be sort of moving towards the northwest, and the waves from the north side of the island will be moving towards the southwest, and they have this crossing pattern that the indigenous navigators there have a word for it, and it's called knit and caught. And it's pretty recognizable. What's more remarkable is they can also see reflections of waves, and so Joe investigated that, and they could see the reflections of waves off an island. And one guy, the guy that he was investigating, he really couldn't believe that he said he was doing what he was doing, because the oceanographers couldn't do computer simulations to show what he was seeing, and their wave buoys couldn't see what they were seeing, and the oceanographers couldn't see what he was seeing. So he went down, the indigenous navigator went into the cabin of the boat to take a nap, and Joe floored it and took the boat about 35 miles to the southeast of this island that they were using as their target. And the guy woke up and he came up on deck, and Joe said, "Okay, where's Arno, the island he was asking for?" And so the guy started describing the wave patterns he was seeing, and then he pointed directly at where Arno was. So he got it right. He got it nailed. And the interesting thing is that they teach this with stick charts, and the stick charts are basically palm leaves that have the fronds, the sticks in the middle of the palm fronds. And you tie them together, and they're used to represent the way the ocean swells get transformed around islands. And so there's a simple one, which is like a teaching tool, but then you have what's effectively like a wave map of a local area, which just shows how the waves bend around. And so I've analyzed some of them and done a computer simulation of the area around some of these stick charts, and they work. It's remarkable.
That
you
is
can actually
really,
see the
really
patterns.
Fascinating. Yeah.
So it's pretty cool. So I started doing it myself too.
That is neat. I was also found it interesting that so on land, wind will affect the way trees grow, like you were talking about. You could see it in the branches and stuff. But when you're out in the ocean and there's nothing really to hold the shape of the wave or the shape of the wind, but actually the waves, the way the swells are, even if you're not in an area that is being affected by wind, the swells can tell you about the winds that are around you. Is that right?
Yep. Yeah, exactly. So if you have a storm system that produces waves, the way the waves get generated, it's a little bit like you get lift on a wing of an airplane. And once you get a little disturbance in the water, as wind passes over it, it'll actually cause the wave to grow. And then at a certain point, it'll get very steep and spill over and then builds up into bigger and bigger waves. But then if you cut off the wind altogether, you'll just be left with a swell, which is a very smooth-shaped wave that will travel for thousands of miles undisturbed. And so in the Pacific, you'll get swells that'll travel for thousands of miles and will be very reliable. You can also tell if a hurricane's coming. This was back in the day before people had satellite forecasts. The stronger the wind and the longer it's blowing, the longer the period between wave crests. So a typical small-scale storm might have, let's say, 8 seconds between wave crests in a swell. But if you have a hurricane, you might get 15 seconds between crests in a swell hitting you. So a lot of times surfers will take advantage of that. In the East Coast, if there's a hurricane, it'll kick up a swell, and the hurricane might be thousands of miles away, but you'll see the swell impinging on the parts of the coastline facing the storm, and they'll go running out and take advantage of it. And supposedly Columbus was one of the first people to learn about the swell pattern associated with hurricanes and escape destruction when a Spanish fleet that he warned not to go out basically got annihilated in a hurricane. So it's a fascinating study, and you can just keep staring at wave patterns all day long once you start to understand what's going on, and it starts to really paint a picture for things for you.
Is there any section that you feel like we left out here that people should know about?
I think that's the important bits of it. I'm just trying to think off the top of my head. For people who would be doing animal tracking, the only other directional finding technique that might be useful, and I hesitate to suggest this because you have to know some detailed knowledge, but sometimes if you're in the right area, looking at airplanes can actually give you some directional information, but you have to be very cautious about that. So I'll give you one example. Out in Cape Cod, I have something that I call the international rush hour. So you have all these airplanes that are flying from New York City to Europe. so that's around 6 p.m. to 7 to 8 p.m. or so, and so they're all flying from the south west to the northeast, and it's very predictable. And the same thing is true for the U.S. at nighttime, because you have all these red eyes that are flying from the west coast to the east coast. So if you know something about the pattern of airplane traffic, and you definitely have to study it ahead of time. I'm not saying you should just trust it, but I do know of people who were lost in the Maine woods, and they knew about the local patterns of airplane traffic and were able to orient themselves with it. So with a little bit of skill and observation, pay attention to where airplanes are going and see if you can use that to give you some directional information. So that's like one more thing you can look up at the sky and play with in your spare time, I guess.
Yeah.
So there you go.
Well, this is great. I really appreciate you taking all this knowledge and trying to keep it alive, and I'm really enjoying it, and other trackers are going to be enjoying it.
Okay.
And once again, the name of the book is The Lost Art of Finding Our Way by John Huth, and I highly recommend everybody check it out.
Okay. Thanks a lot, Garth. I really appreciate it.
Hey,
this is a great time talking with you. Okay. Bye.
Bye.